In this video, we will look at a custom MIDI to control voltage converter. It's one of the projects and sound and music projects for Eurorack and beyond. And this unit fits nicely in a Eurorack setup, and it enables the application of a MIDI input and then voltage to octave output, as well as hertz to volt. So if you have an older synth like I do, I have an original Korg MS-20, I can switch this switch and go between those modes of operation. In terms of modes of operation, there are two primary modes. In the first mode, we have gate output and pitch output, so control voltage for pitch, which typically will be voltage per octave, and that responds to MIDI inputs. It also in that mode has an optional velocity output, so you can use the output to not only control the gate or trigger of a device, but also then use that velocity sensitivity to do something like open or close the cutoff of a filter or amplitude or whatever it is that you would want to do. The second gate in that mode will respond to MIDI clock and send out a signal that corresponds to the MIDI clock. So if you want to synchronize your Eurorack gear to a running MIDI clock, you can do that. So in the second mode, it's really essentially a duophonic mode where there are two channels of MIDI that it will respond to on channel 1 and 2, and of course you can configure that in software, and then you just get the basic gate and volt per octave or hertz per volt output. So let's start by demonstrating some of the modes of operation. So I will plug in a MIDI output to this input, and let's connect a cable and take a look at the voltage per octave output. So I'm connecting ground to the shield, and then the signal will be on the tip. We'll set up our multimeter to read voltage, and let's go to the lowest octave, and we're showing 2.1 millivolts. So for the next octave, 0.98, 1.9, 2.9, 3.9, 4.9, and so on. So I found with the circuits I talk about in the book to have really pretty good output in terms of the accuracy. And if we switch over to the second mode, I'll go to a different channel. Let's check that output as well. So here we have about 10 millivolts, 1.0, 2.0 volts, 3.0 volts, 4, 4.99, and so on. So again, you'll find pretty good tracking with the unit. Let's take a look at the gate output. So we'll plug into gate A and play a note, and you'll see with the circuits I describe in the book, just a little over 5 volts for a gate output. And then if we look at the alternative pitch or velocity output, you'll see, depending on how hard I play the key, so I play very lightly, that was about half a volt. If I play it strong, that's 4 volts. Really strong, 4.6, and so on. So that just gives you a feel for the unit. One thing that I did want to talk about is the form factor, and we'll take a quick look at the circuits here. So I will unplug from power, and this device uses what I describe as a backpack. So this is a single PCB using some SMD components and then headers for a teensy. And that backpack can be plugged into any number of front panels. Now this particular iteration of the project, I used fly wires, partly because I was trying to maintain the same form factor for the headers, 5 on the bottom, and then teensy headers plus several others on the sides. But that's something you could certainly alter. But by creating several PCBs, you could use this exact same design to power things like a control voltage arpeggiator or a genetic algorithm sequencer that I describe in one of the chapters in the book. So if we look at the other part of this, and we have essentially a PCB with the user interface, and then that is married to this front panel, which in itself is a PCB. So fairly inexpensive to build. And even though I have this nice Arturia key step controller that has control voltage outputs built into it, this provides some special functionality that is not available to me. And that to me is the beauty of doing your own designs, is that you can really envision and create a custom device to do just what it is you want. And in my case, I love having the option to have my Eurorack set up, track with MIDI and my computer if I want, with the optional clock output. There's some nice functionality of having multiple channels going on at the same time. So in any case, let's take a listen to how those control voltage outputs work with a synthesizer. And here I will demonstrate with another custom device. This is what I call the Andy synthesizer. And it, although I don't talk about it in the book, the heart of it is the backpack that I use in the final chapter of the book. So just to demonstrate that once you get comfortable with those concepts, the sky's the limit in terms of doing custom builds. So we'll stay in mode 1, and I'll connect the pitch control. I have it set to volts per octave. Connect that to the control voltage input of my custom synthesizer. We'll take the gate output, connect that to the gate input. And why don't we start with that just to listen to some tracking. I'll put on my headphones. Let me turn down the release. So you can hear tracking is very good to my ear. And let's go ahead and start a sequence. So you can hear it's a very capable MIDI to control voltage converter. And let's try one other thing. Since I'm in the first mode, we should be able to take the alternate pitch or velocity output and then use that as a control voltage source. And the way I have this synthesizer configured is that we can use that input to control parameters such as filter cutoff, resonance, amplitude, and frequency. So just to make the point, let's go down to the frequency option, and what you'll hear is I'll play the same note but with different velocities, and that will enable you to hear the different voltages. I'm playing middle C but with different velocities, and you hear that controlling the pitch of the synthesizer. Soft or very light touch. louder touch. So now let's move to the cutoff. So you can hear as I alter my touch, the filter changes. So that provides a short demonstration of the capabilities of the MIDI to control voltage converter from my book. And I hope you're finding some enthusiasm for this idea of designing and making your own custom instruments and devices. It's really a lot of fun and not unduly difficult to do with some work. So thanks.